Let's see. All right. So, yeah, very last lecture, very practical one. It's okay. All right, so let's see. Walter, you are more or less ready. More or less. You can use the GPT. I mean, if the JSON file doesn't work, let's use like GPT. Iago, you also are ready. I forgot your name. Mateo. And Michael, yes. Okay. You say again? Uh-huh. PIL. So this is your data? PIL. Let's maybe look at this later, if that's okay. Okay. So yeah, I mean, I think for today, it was going to be like super hands-off, again, just to illustrate, the power of deep learning these days, and in particular of large language model, about how this can help us to, do science, and in particular here, cosmology. So let me stop this. And I don't know if this is on. It's warming up, okay. Okay. So my recommendation will be for those of you who has everything set up, let's maybe start running this, and then later we will go into detail, how to install the code, what are you doing, and all these things. So, okay, so I have data from William. Where is William? William, and I forgot your name, please. Saba? Isabel. Okay, so let me show you exactly. Okay, so this is the data from William, right? So would you like William to describe briefly what this data is? Please.
All right, so this data is data on strong lenses that's been collected from a variety of different surveys. What we have is spectroscopic data of the redshift of the lens and the source, the velocity dispersion of the lens galaxy, and the Einstein radius of the lens. All of the lenses in the data are elliptical galaxies. So because of this, we have two tracers of the mass here in the velocity dispersion and the Einstein radius. And yeah, so I think that's the very brief summary. I don't know if anyone has questions about that.
I think that's probably good enough. So yeah, this is the data, right, William? So there is basically like a table. This is like an Excel file where you have, I guess, this is the name of the lens, and you have all these properties, right?
Yeah.
And in the prompt we have written here. Well, you have written here like we have a collection of strong lensing galaxies, blah blah blah. Basically, where these come from. We are explaining, what each of these columns are. And then we are just saying that, please come out. I think maybe this should be come up with an interesting idea for a PhD thesis. It doesn't really matter. And that's it, right? So we just have the data, the description, and this. So let's see what this is gonna do. Again, it might not do anything good, but let's try. So this is the code. We're gonna go into detail about this later. What we are saying is, let me increase. So this is the code. What we are saying is that we are in project 10. We have this file, this input, which is the text file that William basically has written. And what we're saying is that generate an idea, generate a research plan, basically do all the analysis with this, and then write a paper. So the data description is in this file, input.nd. So this file, let's open it, basically just contains the description of the data. And the data itself is in this other folder. And this is actually important. We have actually put here that the data is in this location. This is important, otherwise you will not find the data. Okay? So that's it. Any question regarding this? It's really just, you have some data, you put it there. So let's see what if this is able to do something. Yes, let's maybe put it there. So it's because it's going to take a while, and then we go into detail. So for the second one, let's go to maybe Isabel. If you can just briefly describe.
Okay, so I sent you a catalog of X-ray, a cluster catalog of X-rays, was like a reanalysis of Rosato Sky Survey, which is a sort of old survey, but in this catalog, they extend the flux limit. So the statistics actually from very small photo counts, but there's a double identification in the optical with the legacy surveys. So I guess that's general information about it. And the catalog I sent you is the clean one. So we made a few cuts for completeness and redshift and mask fractions and things like that.
Mm-hmm. Okay, very good. So this is what I have written. I haven't shown you this, Isabel. So let me know. I think, well, you wrote this, right? It's just a description of the data. And we are saying that, we have two files. This is what you sent me. So there are these two files.
Yeah, I forgot. I sent you a subsample of that I also use. I don't know.
So why there are two files?
Yeah, because one is the catalog, and the other is a subsample of this catalog that we also have weak lensing masses estimation. So I thought that perhaps you could use it. And there is also, I guess I forgot to say that, but in the second file, which is this subsample, we also have a few measurements with eROSITA data of X-rays.
Okay. So this thing that you have in the header, it describes these things, or this is something that we should add?
Yeah. Yeah, it's just that I took the file. I thought it was easier to take the file from the article itself, so it already prints, you download the data.
I see. But for instance, this thing that you say that it contains also weak lensing information, this is already described here, or this is something that we should add?
Yes, it's described over, yes.
Okay. Okay, so let's see. And we're saying the same thing, right? Please come out with an ambitious project for a PhD thesis. And that's it. So let's see if this is able to do something. Okay, so just open a new terminal, and I'm now going to project 11. Okay, so Python run. So let's see. So for the first project, we already have an idea. So the idea characterizing the mass profile parameters of early type galaxies with a focus on blah, blah, blah. How does this sound, William? This reasonable or? Mm-hmm. Okay. Yeah, let's see. So there are also methods. You know, it's gonna first, you know, read the data, I guess. Then it's gonna unification of physical parameters, derivation of mass profile, statistical analysis, quantification of systematic biases. Okay. Yeah, let's see if this is able to do something. Okay, so these are the 2 papers from our group. Iago, do you want to, or maybe Walter first? It's not working yet, but can you describe the data that they're using?
So, I mean, the thing is that I wanted to get the code working first with some stupid data and then use my group with real data and try to see where it works. But now I'm testing it with just some galaxy mock catalog of log normal distribution of galaxies that I have around. So yeah, the thing is that I didn't know which prompt or how to put a prompt on it, but I just put it to test it. I just wanted to start to study primordial non-continuity on the distribution, and then it's doing the stuff.
Okay. You are using GPT for the analysis?
It's working.
Okay.
But I don't know.
Let's
that's
see. It could fail, no problem.
But it was just a test. So for the people in my group, we should use all the data.
Let's see. Iago, do you want to?
Yes, so the data that I'm using is a simulated catalog from Desk, Open Universe 2024. This catalog has magnitudes, position of galaxies for, I think it was 70 degrees squared, redshift, everything like the true values. And I also added errors, photometric errors, to become more realistic. And right now I'm running this, and the machine learning came up with the idea to study photometric redshifts, which makes sense because I use this catalog to study this. And let's see what.
Mm-hmm. So you already wrote a paper which is like very bad from what you told me before.
Yeah. First, the paper does not have like a good meaning. It's just doing some statistical tests.
Mm-hmm.
Like I noticed this behavior. It usually just do some statistics, see some correlations, and that's it.
Yep.
But I'm using GPT. Maybe Gemini will work better.
I mean, sometimes, you know, it can also produce like stupid things, so that's part of the process. And let's see, Stefano, you want to describe your data or whoever give it to you? Matteo, sorry, Matteo. Abby, yeah, please.
The data we have is a data set from the Cosmic Flows 4 Peculiar Velocity Catalog. So it's combined various peculiar velocity catalogs of galaxies to make a total catalog of 55,000 galaxies. So the data mainly is, you just have, for each object, which is like some of them are objects, are galaxies, and some are like supernova and other low redshift things, but they're mostly galaxies going out to a redshift of 0.1. There's log distance ratios, which can, with a simple formula, can be converted to a peculiar velocity. And then you have, for the coordinates of the galaxies, just the redshift in the CMB frame and like right ascension and declination, basically, yeah.
Okay. So you say, Matteo, that is not working, but it's not working.
I think he's having problems with the credentials.
With the credential.
Yeah.
So try to use like the GPT for the analysis, and with the keys should work. Yeah. Still, I don't know why. Yeah. All right. So any question regarding this? These are the things that we're trying to do. And again, to illustrate really, these days we're able, the fact that we are even able to do this, I think is really impressive. Any question? If not, let's then maybe describe now things in detail. So, I'm coming here. This is the repository where, again, all the information is there. So I have just a few slides about this. And I just want to explain how these things work. So the way that this code works is that, you start with some description. And, these are the files that I have shown you before from William and from Isabel, sorry. Where you basically, describe the data, but you can also put other things. Like, for instance, you can say, OK, I'm running the code on a cluster, so I have access to a GPU, maybe 10 CPUs, or any computational constraint that you can have. Anything that you want, you can put it there. And then, the way that this works is that we have like 4 different modules. And you should think about these modules like a set of multi-agent systems. For instance, yesterday, we basically wrote a simplified version of the idea one, where we were just basically taking like a topic. And if you remember, we have this idea maker and this idea hater. They were talking to each other for a few iterations, and they will come out with an idea. Okay? So that's the very first module. And the other thing that I want to emphasize is that this thing has been designed in a very modular way. So for instance, you can just maybe use this code to just generate an idea, or you can use the code to just make a research plan, or maybe just do the analysis, or just write a paper. Okay, but in principle, the way that this works is that it will first generate an idea, and then this idea is going to be passed into another agent who is going to take the idea, and is going to take all the description of the data, the computational capabilities, and these things, and it's going to make a research plan. It's going to do, OK, so you need to first read the data, first, next you need to normalize the data, you need to train this model, and then you need to do a statistical analysis, blah, blah, blah. So then there is the next module that is going to take, the idea, is going to take the research plan, and it's basically going to do all the heavy lifting here, right? So it's basically going to go for each of these steps, and it's going to write code, it's going to execute code, and it's going to make plots. And at the end of the day, what this is going to give you is basically like a set of plots and a description of what was the analysis that it has done. And then the very last part is this other module where what you are going to do is you are going to take the idea, you are going to take the research plan, you are going to take the plots and the results, and it's just going to write like a paper. So again, imagine that you already have, for instance, plots, and you already have the results, and you just want to maybe write the paper or a draft of the paper. You can just use this module with basically these 3 different, let's say, properties. Any question regarding this? So yesterday, we described this in a lot of detail. We have these 2 agents, the idea maker, who is basically producing an idea, and then we have the idea hater, who is criticizing the idea. They talk for a few times, and then they basically come out with an idea. And you saw yesterday, I think, that how simple this thing was, and you can basically now create your agents for any other thing that you want. To make the research plan is really very easy. You basically just input the text that you have. You also input the idea, and this is basically passing into an LLM, and this is just going to give you the research plan. So this agent is really, really, really simple. The most elaborate part of all this thing is, like the analysis part. For this, we are using the CMB agent that Boris and many others have developed, and it's really an amazing work that I will recommend, and we will use later. So this is really like doing all the heavy lifting here. And as I say, it's basically going line by line in the research plan. It's going to write code. If it needs to install a library, it's going to install the library. If there are bugs, it will fix the bugs. It will make plots. And at the end of the day, it's going to produce a summary of the results. And this is like the last module. That is the one writing the paper. And the idea here is that you have a lot of agents, but there is an agent who is just in charge of finding the keywords. Right now, it's only able to find astrophysical keywords. That's why some papers in medicine, in biology, they are like super weird, right? It's like, and then you have agents who are gonna write the abstract, write the introduction, methods, results, conclusions, and this thing. Raúl. No, I think, for instance, in this particular case, it's like, how do we write the paper in principle? You write first the abstract, then the introduction. In reality, I never write the papers like this, right? You always write the results and these things. But yeah, I don't think probably, for instance, for writing papers, I don't think it matters too much once you have all the files. For the analysis, of course, right? It has to be sequential to some extent. So in that case, yeah, you have to play, and Boris have done an amazing work with this. Other questions? Well, at the end of the day, it's just this. You have all these agents. Some of them is gonna, for instance, go through the plots to create like the captions, and then we have even like a citation agent that is gonna put the citations. So in principle, it should look like a full paper. Okay, and as I was saying, you can run these things in a modular way. You can maybe just generate an idea. For this, the only thing that you need is the description of the data. But maybe you can just write a paper, and to write a paper, you just need like the input text, the idea, the methods, the results, and the plots. And I think that's all from my side. Just to give you a little bit about how this multi-agent system works. Any question regarding this? Okay, so if not, let's try to go into more detail. So let's see if this fails. Okay, there is a paper already being written here. I'm always suspicious when a paper is written so fast, very suspicious. Yes. I mean, the paper for David still has been running, but yes. So, okay, let's wait. Let's take a look at this, but yeah, not sure. But the data that you sent me also, William, is relatively small. So, maybe it has done something very simple. I don't know. Let's see. So, let's come back here. So, the way that this works is like, these are kind of instructions on how you can use this. So in principle, you will need like an API key, and yesterday we went through this. You can get, for instance, an API key here from Google. It's free, but I think you cannot use the latest model with this one. If you want to use the latest model, I think you need to pay, or there is a free trial for this, but yeah. Then, the way to install the code is basically just, these instructions. Should be like relatively simple. So basically, you need to clone the repository. Then you will go into basically the folder that it creates. Then it's going to create a virtual environment. You will just source the virtual environment, and then you will basically install all the dependencies and all the code that is there with this. So, I mean, Walter Josistoli, Iago, I'm very bad with names. Mateo. So, you can try to install it. If you have any problem, let me know. Yeah. Then the second thing that you need is basically to set your keys. If you remember, for all these things, we are basically calling large language models that are run somewhere. in some cluster. So for this, yeah, you need to basically tell the system what are these keys that you need to run it. So, basically the way to do this is to create a file that is called this .n from environment, I guess. And basically you will put these things. And here you will put your key from Google. This in principle should be like this. And if you are using like OpenAI, then you should put your key here. And then, this is like the way that, as we discussed before, the way to run the code. So you just import the library, and from the library you import like let's say the main, I don't know, core or part. You just say where your project is. Oh yeah, please, there is a question. Oh. I see. So it's not even able to import it. I see. Are you sure that you have done this? Yes. Oh, sorry. Okay. Mm-hmm. I see. I will need to look into that, yeah. I cannot tell you, yeah. This thing? You did this part, right? Yeah, I don't know. Let's look at it later. So, basically you define the folder where, your project will be. You define this input file that is basically a description of your data or a description of the capabilities that your computer has. And then here is where you can do whatever you want. You can, in this case, this is the way that you generate an idea. This is the way that you generate the methods. And this will be the way that you do the full analysis. But you can see that these lines are commented. So, with the Gemini API key, everybody should be able to run this code until here. So that should work for everybody. For this one, we are having problems, as we are seeing. So if you are having problems, but you have an OpenAI key, you can just, I think, maybe this is not updated. You can just use this line. And with that line, it should work. And then this last line is basically to write the paper. In principle, to write the paper, we are using Gemini Flash. So in principle, this is also free. So you should be able, if you have some data, for instance, if you have already made all the plots for your paper, you can in principle write a paper or a draft. Again, you should always check all these things and don't just trust blindly. But with this, you should be able to do it. And here there are some instructions for those of you that are using the Gemini. Let me remove this line because it's confusing. And yes, there was a question or not. And I think that's it. Let me see. For instance, imagine that you would like to just write a paper or write a draft, given all, all the plots that you have. So the way that you will do this is like, you will create a folder, and then inside the folder, you will create another folder called plots. Then you will put all the plots that you have inside that folder. And then you just need to create these 3 files, like idea.nd, methods.nd, and results.nd, where you will put basically the idea of your paper, the methods that you have been using. So it's like, okay, I've been doing some NCNC with perturbation theory. You will write here the results that you got, and that's it. Basically, with this, it will write, in principle, the paper. This is something that we did the other day, so I will not go through it again. Any question regarding this?
So the Google API key and the OpenAI key, they are both required?
Yes. For instance, with the Gemini key, you can run the idea, the methods, and the paper. But for the analysis, you need to have both the Gemini and the OpenAI. I can send you my key if you want.
No, I think I did the process yesterday. I got the key, but I don't remember if I got one of the two or both.
You only got like the Gemini key.
I got them, okay.
Other questions? Okay, so let's see. Okay, so one paper here finished, so let's take a look. Again, always be careful. So let's see. Okay, so here, you can see that it's missing a little bit of the abstract, so let me just open this. Because usually, every time there is this kind of symbols in LaTeX, it might be a bit, but it should be just this. See? Okay. So let's see. Robust constraints on early type galaxy mass profiles from strong lensing, addressing systematics from heterogeneous data. William, you might be more familiar with this. Does it make any sense or not? Okay. Let's see.
But it doesn't sound very new, right?
It could be. It could be.
It's just the best sequence file and larger mass.
But remember that, for instance, Raul, this is something that I have seen many times. So when in this case, we just describe the data, right? So then it's much more likely that it's gonna do the standard analysis, right? Because this is like the most logical or obvious thing to do. If now in the prompt, for instance, we say, okay, look, you have already done the standard analysis, do something else, it will do it. Mm-hmm. Let's see. I think it was like, yeah, but I don't think we put for this particular prompt. Let's see. So this is the prompt. I always add this to the, I only put do not create dummy data. Yeah, exactly, for the merger trees, but I didn't put for this. Okay, so let's see the plots. If there are plots, I don't know if there are plots here. Okay, so this is, I guess, the distribution of the parameters, maybe William, or? Distribution of K physical parameters for the 200 galaxy lens. Yeah, I don't know. Let's see. Okay. Some of these plots are quite elaborate, right? It will take me time just to do this. Do you know, William, maybe you should explain if you understand anything here. Let me give you the mic.
So distribution of, so here it seems like the plots on the left are computing the predicted velocity dispersion from the Einstein angle using a singular isothermal sphere. And on the right, what's the distribution of mass profile? So this is the. This seems to be the. This is the F sigma on the bottom one. So yeah, this seems to be their computation of the mass profile. So I'm not fully clear on how. I'm not fully clear on how. I think it's to do with it's going to be the difference between the something to do with this ratio between the predicted velocity dispersion and the one computed from the Einstein angle. The ratio of those two, I think is going to be related to that.
These are just correlations, I guess. I mean, it might be like a very simple analysis, what it has done here, right? Okay, I can send you later the paper. Maybe you read it carefully, and we can put in the repository if this make any sense or not. But you have seen, 25 minutes, at least for the plots, it doesn't look bad. And again, I think it's quite impressive, right? At least from a very first look, doesn't look like a completely crappy, no? I mean.
Yeah, no, it looks definitely on the surface, it looks very good.
Okay.
So the Einstein angle is, I guess you can say it's the deflection angle when you have the source, the lens, and the observer all lined up along the line of sight.
Okay. So this was one. Okay, so the other, it seems that it has failed. It fails when it was writing the conclusions. Let's try to run it again. Sometimes it fails for a lot of reasons.
So if you run the exact same thing twice, the results vary a little bit?
Yes, in this case it's going to... Exactly. So in this case, the temperature is not set to 0. So the paper, in principle, I mean, the content should be the same, but yeah, even the analysis might be different. So let's see for the other one. So just to show you, this is, for instance, all the code that it has written. And what I like about this is that this is, in principle, like the most reproducible paper that you can have, right? You get everything. You get all the code, so you can reproduce every figure. You can go there. If I run this code, it's going to give me exactly the figures that are in the paper. In the figures, no, because the figures you can see here the code. It's like, this is really what it's doing. So that's the thing that I think is super hard. So, it could create like crappy thing, right? But to create something that works, I think that's really almost impossible. Hallucinate to produce the correct result, that's super hard, right? So I have never seen this, and I think that's super hard. It can hallucinate with text for sure. But for codes and figures, I really trust this thing. So you see, you can come here, you have all the code. Say again, Miguel. Oh, yeah, no. If it writes an hallucination for the code, it's going to be there. But this hallucination might create bugs or might make plots that doesn't make sense. And yeah, you can have plots that doesn't make sense. But that's what I'm saying. Then in the paper will be bad. Yeah, no. The hallucination is really... Yeah, exactly. So, again, we have all the code here. And let's see. So, the plots, the plots are already here. And let's see, so, you know, very beautiful plots, I will say, right? Much better than my crappy plots. Yeah, I mean, it's putting the figures. Let's wait a bit. Okay, it has done an NCNC for this. David, I've been waiting hours for yours, and in this, you see, 5,000. Yeah, but okay, let's wait for this, and then Isabel, maybe you can briefly comment when we, yeah, Raul.
So you have several steps there that inform the final thing in the codes, right?
Mm-hmm.
How easy it is for us to go to the generated files with those instructions or the summaries of those things and input ourselves stuff in there. We change what's in there by hand and steer more to what we think is interesting.
Mm-hmm.
Does this create instabilities like inconsistencies now? Because I'm asking this because it may be that I have a great idea and I think I've done something, but my documentation is poor. I didn't really write down many things, and I just want to have something which is kind of summarizes what I've done. So I tell it exactly what to do. Is this easy to do, or it's better to prompt and have several iterations, or we go to the document directly and edit there?
Yeah, I think you can do both. You can have human feedback at any point in this step, so you can always, say, okay, improve this or do exactly this and this thing. Sometimes it doesn't follow your instruction, right? It's like, and the other question, yeah, but in principle, yeah, you have full control. But these kind of things are really designed to be fully autonomous. So you can have human feedback at any time, but I think in the future, this will be like fully autonomous.
Is there a way to force more human feedback, more iterations of that? Is this an option, or this is hardwired at the moment, maybe in the future?
Including human feedback is very easy.
Just include more loops of it.
So it's super easy. The only thing is that, of course, when you run this thing, in this case, it took 20 minutes, but imagine that it takes like 2 hours, right? Then they will have to wait for a human to go there, give feedback. So, I mean, it could be done, but the way that I think we're thinking about this is like fully autonomous. It itself should get all the feedback and all these things. Miguel.
Yes, so I'm still trying to understand, because we all see how these LLMs hallucinate, right? I mean, I'm still trying to understand. So they hallucinate every now and then, right? We try to correct it. Now this is doing a lot of steps itself. So I would guess probabilistically there should be at least one hallucination anywhere. And you're saying there's one hallucination not correcting, it's going to correct. So how come most of these papers are being written and not correcting? I don't understand. What is correcting there?
Yeah, I mean, you can have hallucinations, but there are agents trying to improve these hallucinations, right? So you have agents that are taking basically the prompt and is taking the result of the other agent and checking is like, does this make sense? Or maybe here you hallucinate. So we have a lot of these things. But yeah, at the end of the day, you cannot fully trust this thing, right? Yes, the more agents that you put, the more robust that all this thing is going to be. No. I mean, this thing inside, there is really a lot of things. Yeah. I haven't fully described. This is like very complex. Yeah. Yeah, Iagos, yes. He wrote a paper. Okay. You got interesting, sorry, let me give you the mic.
So I just gave my catalog, and then it ran an idea. And the idea is to estimate photometric redshifts using a type of networks. And I then copied this and looked into archive, and I found a paper that was published 2 months ago.
Mm-hmm.
So how often is these models being trained? Because I'm not sure if the model copied the idea from there, or if it's kind of new idea.
Yeah, that's a very good question. If the paper is from 2 months ago, I don't think it will have been trained. These models, even the state of the art that we're using, I think they were trained at the end of last year.
Wow.
I think this is like Gemini. So, but for instance, you can imagine that you can have, and this is what people do, you can have, when you generate an idea, you can have an agent who is basically looking into the archive or looking into Google to see if this has already been done. So this is a little bit what we do to check that what we produce is really original. It has not already been done. So you can have agents really for these things. Mm-hmm. That's a super good question. I'm not an expert on this. Yeah, I mean, hallucination, I think, is one of the biggest problems of this. People in industry, they really think very deeply about this, but I don't really know, yeah, in terms of quantitative statement. Mm-hmm. Yes. So, I mean, let me put it in this way. In terms of the quality or how interesting the papers are, I will say that out of 10, 2 or 3 are semi-reasonable. So that's a little bit the statistics. There are papers that are completely crap, right? And let's be honest. So that's why, yeah. But I will say, I was expecting that maybe you will need to run 1,000 times this to get something reasonable. That's not the case. That's not the case. Please. It can do citations. So the way that we run it here, you can see that it's like add citations equal false. If we put equal true, it's going to put citations. I say that the citations are not good. Yeah. I believe that's not the way that it works. So for citations, let me maybe show you. For citations, we use this other LLM. Oh, sorry. That is called Perplexity. Okay. So this is an LLM where you ask questions, but then you get an answer with citations, and these citations are true. So let's ask something. I don't know, Manu. Tell me some question about CMB or something. Was the CMB detected? But something more technical. I don't know. That's still maybe not super technical. Let's see. Okay. Say again. No. I like that one. Say the question again. Okay. So let's ask this. So, this is the question. It's going to give us an answer. Hopefully it's right. What do you think of this, Manu? Okay. I'm going to go to the citations next. Second paragraph is good. Okay. And, it's basically taking this from this source. You can go here to the archive, and this is the paper, I guess, that is looking up, right? And this is like an actual paper, right? Is there. And I guess this paper is relevant for this, Manu, maybe you know, or you don't know this paper? Yes. I don't know exactly how they do, but I guess maybe they will have an agent looking into all this paper, doing the RAG, what we discussed yesterday, and doing this matching. So in this case, it's giving you, the references. So all these are the sources that is looking. There is this paper, this other paper, which is like very, very recent. Well, this is the same one as before. Yeah, these are the same one. It's also looking in Wikipedia. And yeah, I don't know, maybe this paper, maybe. Yep, yep. So this is the way that we get the citations. And, as for instance, this paper, maybe this is not the most relevant paper, but maybe there is something there that is semi-related to it. So that's the way that we get the citations in our case. Yes, Raul, I think the other paper, let me just open it. And, okay, this also, it's amazing. It's able to write a paper, but then it's not able to put here like this symbol. Yes, Raul. And then Isabel, give us feedback when you. No, please, please.
So let me ask you a question. So I don't want to make a paper. I want to learn about stuff. Like I haven't attended the school, or I didn't pay attention. I was sleeping here because I went out last night, and I just want to recompute some calculation, which is kind of standard textbook, but I want to learn in the process. There's a way that I can prompt this so that I can learn. So it's not a scientific paper in that sense, but it's more a didactical paper, and that tells me what steps I have to do, which calculations and so on. Is this something that can come out with the proper input?
Yeah. This is a little bit actually what I do in these days. For machine learning, still every day there is like new methods and these things. So many times I say, okay, if I will want to do this toy problem, can you write a very simple script so I can really understand this thing? And then from this, I'm probably able to do this thing myself. That's why this thing is also going to affect teaching, I think, the way that we teach. And that's why I think it's very important for you, all of you that are very young, to really learn these kind of new technologies. Because this is something that, is really, for those of us who have been doing, pen and paper almost, this is really amazing, I think. And still, you have to be careful with everything, but learn to use these technologies really well. This is really the most important point that I want to say.
So I'm curious about the part of the, let's say, the set of tools that this model is using. Because it can look at Google, look at archive, etc., etc. But there are methods to use other kinds of tools, like I've seen agents that can generate and recognize pictures, for instance. So in this setting, how difficult would be to include more tools? Because, for instance, if I wanted to know, I want an agent that can do that data analysis, but I also wanted to generate Mathematica, Wolfram Mathematica script so that it can do some sort of calculations. This kind of stuff. How easy is it to integrate new tools in this framework?
It's super easy. It's super easy to integrate these things. And every day there are like new tools to integrate this more. So, for instance, recently Anthropic released a thing that is called MPC, where, for instance, all these agents that we have now to integrate, to write papers, in principle, anyone can take this agent and just be like, when you, for instance, I don't know, when you write a Python code and you import your library, so in principle you can import all these things, and this is an agent who writes papers for, for maybe other applications. Okay. So it's super easy to integrate all these agents, and that's why people are thinking, again, I know that I'm expert on this, but I think, maybe the most sophisticated system has thousands of agents. People are thinking, what will happen when we reach millions of agents, with all these kind of, capabilities, right? People in industry are investing a lot of money in these things.
Thanks.
Okay, so Isabel, did you take a look? And feel free, if this is like very bad, please say.
No. No, it's actually good, I guess. I don't know if that counts, but on the file I sent you and the header, there was the title of the article, and it's been out for a few, I don't know, couple of months, so perhaps he doesn't know as well about it, because it's kind of the same thing, but actually he uses only the Rosetta, I think, subsample. So only 42 clusters. And, well, I guess he didn't do all the statistics and all, and he found a very, I don't know, weird result. But the idea of doing the scaling relation, the mass luminosity scaling relation, but I guess it was kind of like we gave a cluster with X-ray luminosity and weak lensing mass, so I guess we kind of set them to do this.
But let me see if I understand. So you say that what is finding is not what you are finding. So maybe fail in that case.
Yeah, but I think I can understand why he did that. We made some selections and saw that it was very important to consider those. So it's not so bad. It found a result that would be expected.
Okay, so basically you did some selection that probably he didn't do it.
Yeah.
Okay. Yeah, so for instance, this is something that we have seen with a lot of other works, and these are works that are not really published. So this is the NCNC that it looks beautiful. Again, I can share with you and feel free if this makes any sense.
Yeah, I would like that. Thank you.
But for instance, with the people that working right now with neuroscience, they have done some analysis of bats. I don't even know why people study these things, but and basically, they haven't really published the paper. But what this thing is able to do is basically do something very similar to what they have done. But they really want to do something new, and that's a little bit harder. So I'm not surprised that, for instance, it's able to do something similar to what you have done. I don't think it's because your paper is out, but maybe because it was like kind of the, maybe the most natural thing to do. Yep. But still, it did faster than you, I guess, no? It looks beautiful, right? I have no idea what is this, but yeah. So yeah, again, I'll send with you, William, and then we can put in the repository. And again, if it's bad, we say, right? We don't want to cheat or lie here. More questions regarding this? If not, I can show you maybe some simpler agents for other things. So let me see. So, there are here other kind of agent. So give me 1 second. So I'm gonna remove this thing because I think I'm recorded and I don't want to share my key. So 1 second, just so I take my key. So I'm gonna take this thing. I'm gonna put it here. And now let me come back to this. So for instance, this is gonna appear right now. This is a set of agents, much more simple, that is very similar to what we did yesterday, but basically designed to do simpler tasks. So for instance, we have this camels data where we have really a very large data set, and something that you can do is, so let me put here. So for instance, if you use these simulations, every paper that people write, the description about the simulation is really always the same, because the data is what it is. So, it's really just a slightly different way of describing the data. So one thing that you can do is to have maybe an LLM to basically just do this thing for you. Again, you should be careful if you really do this in practice with a journal and this thing. But, I think this is the kind of the things that I'm not sure if, even for me, spending maybe one day writing this is really worth, because this is really the same thing that has been written 100 times. So, yeah, I mean, I know there are, things about plagiarism and all these things, but, you can, in principle, just have an agent to write this section for you. And, you can also iterate, chat with the agents to, you say, okay, so change this part, change this other part, and yeah. So another thing, for instance, and this is something that I think many people are doing now, and you will see later for the class code, for instance, the documentation. I'm sure many of you, you write a Python code or package, and you have a documentation. And, if the documentation is very good, it's going to be like a very long documentation. And, sometimes you just want to do a very simple calculation. Maybe you don't want to read the full documentation about everything. So what you can do is to chat with the documentation. Again, sounds weird, but this just asking is like, I want to do this, tell me how to do it. So this is, for instance, what we did, is like you basically put all your documentation that maybe you have in read the docs or whatever, and then you say, okay, so I have a question, so let's put a question. It's like, how can I download the data using Globus? So, I have this CAMOS data, I want to download it, but I don't want to read all the documentation just to get this. So you can ask the question, and it's going to basically tell you exactly the thing that you really care. You don't have to read everything. So this is very good. It's just taking basically from the documentation, and it's doing what we described yesterday, this RAG. Retrieval, augmentation, and generation. So I'm not sure if ChatGPT knows about this package, but what I'm doing is basically putting all these documents, splitting, and then I'm just doing a cosine similarity. And it's giving you a super good answer. Like, this is really what you should do. Yeah, Ricardo.
Yes, okay, I have my data, so I input my idea, I say elaborate on this idea using this data, but then this will become knowledge of OpenAI, of ChatGPT, so there will appear into the answer to some other physicists elsewhere in the world.
At some point. But if the data is still private, it will not use it. I mean, if you use these API keys, I think ChatGPT say that it will not train on your data. So it still will keep it private. So far, I mean, you don't know, but I mean, it's written there. We have to be careful about this. So you see, I mean, if you have some documentation thing, or even a paper, you can chat with your paper. Sometimes it's like, oh, this paper is super long, I just want to. So in principle, you can embed this, and you can ask questions to the paper, and you will go directly into the point. So another thing is, for instance, literature search. So for CAMOS, for instance, I think more than 100 papers has been written. People write to me. I have not read all these 100 papers. So sometimes it's like, I don't know. I mean, David, recently, your students sent me an email. So I asked these agents. So for instance, let's say, I don't know, things that has been done, I don't know, let's say, baryonic effects on the matter power spectrum. So what this is doing is basically going through the abstract of all these 100 papers, is basically embedding the abstract, and now given the query, it's going to find the most similar things. So it's going to tell you, what are the relevant papers. So for instance, there was this paper predicting the impact of matter clustering. So this is like very relevant one, yep. And it's giving you here the archive link. So this is like a very relevant paper. Constraining the effect of blah, 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 with fast radio bars, maybe not so relevant, but, this is really already like a list of papers that are like relevant. So to do also things like literature search, and this thing is really is really, really good. There are agents, so this is an agent that I didn't write, right? So this is something that is called Scholar Semantic, I believe. So this is amazing. You know, the whole archive is embedded there. So you can really ask any question here, and in principle, it's going to go through the entire archive. So let's try to do something very specific, because otherwise, you know, we will find thousands of papers. So let's say, I don't know, the impact of cosmic rays on, I don't know, the intergalactic medium, something like that. Okay, and it's going to give you these papers. And again, these are not Camel's papers, right? This is from, yeah. So Euclid, I'm not sure why Euclid will be relevant for this. Maybe. But yeah, but this is basically looking into the whole archive. So that's why we were talking before that, you know, you can have agents that you generate an idea, and then you can check if this thing has already been done or something similar, and then you can, you know, you can create new ideas in this way, where you can more or less guarantee that, you know, this is really, really novel. The coding is, I think, the most impressive part, and you know, I think you have seen already with all the plots. But you know, here you can say, you can ask for very, very detailed questions, right? So for instance, write a code to compute the power spectrum of subfine galaxies. Subfine galaxies just means, you know, one particular code that we use to identify galaxies. So write a code to compute the power spectrum of subfine galaxies with stellar masses above 5 times 10 to the 9. Okay? So, you know, this is really a very detailed question, right? And basically, this knows already, you know, all the data format in camels. It knows how to compute the power spectrum. So it's going to write basically a code to do this.
Paco,
yes.
All you need to use this is to have an API key from Gemini. Key. That's it. You upload that, and then it's done.
And it's done. Okay, so this is the code that it wrote. And again, this is not very different if you do this in ChatGPT, right? In this case, it's just that it's like tailored for camels. So, you know, this is the function. You know, here is opening the file. This is reading the position of the galaxies. This is reading the stellar masses. With this, is taking only the galaxies above this threshold. You know, it has also this very nice thing about the check-ins that I usually don't do in my codes because I'm lazy, but with this thing it's very easy. And this is really computing the power spectrum. So you see, it took like 1-2 seconds. You should always check the code, but this is very nice, I think. And it gives you even like a very detailed explanation about all these things. Okay. Questions regarding this? Blood magic. Okay, so let me show you another agent, you know, the CMB agent that we were talking before. This has been done, you know, by many people, but Boris Bolliet is really the person of reference here. So, you know, you can just go to this website, the same thing for camels, you know, you can just go to this website and, you know, you can use these things, or you can build your one for your data, your documentation, your paper. It's really, really easy. So, you know, this is for CMB agents. So let's try to do something more maybe cosmological. So let's use, I don't know, the planning and control strategy. Okay, so where for the engineer, want to use GPT-1 for the researcher. For this, so let me, sorry, give me 1 second, so I put my keys. Basically, yeah, you just need these keys. So I'm going to put the one from OpenAI, and the other one from Anthropic. Oh yeah, sorry. Okay. Sorry, 1 second. Okay, let's see. Not sure if my OpenAI is working, but for instance, Boris has here some, examples. Okay, so for instance, conduct a multi-step analysis of CMB polarization data, simulated data for the analysis. So let's see if this works. So what it's going to do is, it's basically the same that we have in Denario because it's really the same thing for this. So it's going to do, a very detailed plan. It's like, okay, you need to simulate the CMB polarization data. Again, I'm not super familiar with these things, but and yeah, so it's going to basically is making all this plan, very elaborate plan. And now it's going to go basically each of these steps. In my understanding, is going to write code. You see, it's step number 1 is calling the engineer, which is one of these agents. It's going to, I think, write code. And for this, after this, it's going to, I think, probably make a plot. Raul, please.
Yeah, I'm sometimes confused about where things are actually running. Where's the data processing? The LLMs are within some machine for Google somewhere, but at some point you're simulating something, right? That at which point that switches over to your local machine or to a machine that you stipulated, in this case, CMB agent. Is it using a server for CMB agent? Is this something that's clear?
Yeah, let me maybe make a drawing. This is very important, Raul, yes. Yeah. So you might have your system, right, here, let's say system. And every time that you call a large language model, this is, in most of the time, is really done outside, right? So this is like, in a cluster, in some cluster somewhere. And that's why usually you need like an internet connection. If you use, like, for instance, DeepSeek, it's local, maybe you can do it, but in most of the cases it's this, right? And that's completely outside. But then what this is going to do is going to, let's say, for instance, is send you back, and the system is maybe write some code. Okay, so blah, 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 blah. And then this code needs to be executed somewhere, right? So for instance, in the case of Denario, when we were writing the papers, my laptop was running the calculations. For this particular case, if you look above, we're using this Hugging Face. So this Hugging Face is a super popular thing for machine learning, where basically people put data, put models. It's an open source, so everybody in machine learning use this. And basically, they give you some computational resources. I'm not sure what is this. Maybe this is going to give you like 2 CPUs. They are not giving you GPUs. But there are 2 or 4 CPUs somewhere in the world. And this CPUs is the one that we are using to run this. So this thing is not being run on the laptop with the Hugging Face. So that's why, if you develop one of these agents, you can put it there, and you will have some resources already to execute this. So let's see. Okay, so it's doing something. You can see that this, it's really elaborate, this thing, right? It's really, okay, so it's even installing things. Yeah, I'm not sure how long it's going to take. But, this is kind of the way, okay, now it's doing the step 2. At the end of the day, it should make you like a plot. Hopefully, we'll finish soon.
The agent is already there, or you prepare it?
No, the agent is there. It's in the code. But remember, this agent is really calls to large language model. So there is really no training or anything. It's a prompt in most of the cases. And yeah, it writes so much code, right? That, if you... it takes us like a lot of time to just go into detail if we want to do this. Yeah, I'm gonna leave this running here, and I'm just gonna show you the very last, another agent. So this is change of password. Okay. So sorry, let me put my too many apps and. So this is another agent that it has been developed by Santiago Casas, Christian Fiedler, Julien Lescourt, Boris Bolliet, and I have only contributed a little bit, where basically the idea here is that they take a look at class, which is a very sophisticated code. The documentation there is even longer, very elaborate, and basically is doing, among many other things, this rack process. So basically, yeah, you can basically chat with class. Even for me, these days will be very hard to read everything there. And you can, in principle, just ask him to write the code for you instead of, you maybe have to be coding. So let's see, can someone tell me a prompt? I haven't used class and CAM in a while. I don't know. Write a code to compute the, I don't know, TE power spectrum. Does it make sense? Yeah. Okay. So let's see. So, it's basically going through the class documentation, and it's basically giving you the code. It's also giving you the explanation. And I think we can also execute the code. So let me see if we can do this. So let's say run last code block. And this should be able to produce. Yeah, maybe I haven't installed it. There are so many agents recently that it's even hard to. So, maybe I have to first install it. It's also trying to fix the code by itself. Okay, not sure if it did it. Maybe we need to install it, class. It's running, it's installing things. And this is also running on the cloud, in this case in Streamlit, which is another, let's say, server or. And let's see if the CMB agent finish. Oh my God, by changing the, okay. Okay, sorry, I didn't know that it will, okay. But you can play with this yourself. And maybe now it's gonna, because I move.
So none of this is running in your machine here, right?
No. This is running on the cloud.
Oh, that's the other thing, right? I mean, have laptops, are they quickly becoming, like, I mean, you might as well just have a tablet or something. I mean, computing power locally is this still something you use realistically now?
The resources that you get in this kind of places are very limited. So, they give you maybe 2-4 CPUs. These are maybe not like the best CPUs. So, for heavy calculations, I will definitely not. So I think, at least for me, still I will use my laptop for the foreseeable future. So let's see if this is running now. So before I tried it and it was working very well, but I'm probably using this incorrectly. Okay, it doesn't really matter. Yeah. So, yes, please, Walter. Yes. Yes, yes. And you have here the flexibility, so they have like OpenAI and Gemini API keys. You can, in principle, choose whatever LLM you want.
One of them might work better for solving.
Yeah. Exactly, exactly. Even for this, yeah. The LLM is the central role. It plays the. So this is all I wanted to say. Before maybe going to the question, I would like to thanks again the organizer for the amazing school. I have a terrific time. I think I'm pretty sure with David and Manu. And yeah, I think it has been really, really amazing for all of us. So yeah, thank you again for everything. And
I don't know about you, but I have the feeling that my life as a researcher won't be the same after this school. You have the privilege to be asking one of the last questions of the school. So.
What about the papers? Any success or not? No. Is what? Is doing. Okay. Okay. In your case, nothing. Okay. We can look at it later. And I'll send you later the papers. And again, whatever it is, we write in the repository.
Okay, it's Friday night. No, yes, go ahead. Does it work?
Oh, yeah. Sorry, you mentioned this already, but for just brainstorming ideas or for learning about a topic that is known, what's your tool of choice? Like to ask questions like that one about radiation driving or something, when it's something you know that the field knows about, you just don't know about it.
Yeah, so for instance, these days, for instance, I would like to, for instance, learn more about diffusion models, these generative models. I'm not an expert on these things, so usually what I do is like, I go into ChatGPT, it's like, write some very simple code to do this very simple toy model. So it's going to give you like a very short code that I'm going to be able to understand very well. And already with this, I'm already learning a lot, right? And yeah, with this, I'm either able to just do this myself, or maybe I ask him, okay, so do this maybe more complicated, or explain to me this thing. But even for concepts, it's incredibly good to explain. And I don't know if you guys have played with this thing that is, I forgot the name, but it's called LLM. No, LLM, like LM. So basically, it's like you can put a paper there, and it's going to make a podcast about it. Have you seen, right? Some of you. Do you remember the name? We can try to do. It's all.
Notebook LLM.
Say again. Notebook LLM. It's amazing. I mean, you will see. Let's see. If it should only not. And I was really, really impressed. Okay, so I think it's this one, right? So basically, you just put, let's see, create new. Okay, so let's put, I don't know, I should have some paper in my, I have so many things here, don't look too much. Okay, maybe none of these. So let's go quickly into the archive. Let's download Clara. Okay, so Clara. So I'm gonna download Clara. I'm gonna come here. I'm gonna upload Clara. Where is Clara? It was in my desktop, right? No. Oh, downloads. Oh, if it's in downloads. Are you sure it was in downloads? What do you mean last time? It was not in, I think it was in desktop. This one. Okay, so I'm gonna just put this thing here, and I'm gonna ask him to make a podcast about this. And again, this might sound like ridiculous. I tried this the first time with some Camel's paper, and you cannot have an idea of how good this thing was. I forgot. Do you remember, Natalia, where this was? But audio overview? Come back in a few minutes. Okay, it doesn't finish, but believe me, explaining concepts that were like incredibly difficult, I mean, you know, things like agent feedback or things that it's not, I don't know, it's not super maybe intuitive to explain this thing, it was really amazing. So basically there are these two persons who are talking about your paper and explaining the concepts, and I mean, it really blows, it blows my mind. It blows my mind. So again, I will strongly recommend that you play with this. And I'm pretty sure I have some files somewhere, but yeah, sorry.
Okay, so it's probably the time to thank all the participants in the school. A special thank to the main organizer, Rogerio. And yes, the technical staff and the speakers. And we finish.